Okay, team, welcome back. It's time to get ready for exam 3, last exam of the semester. I'm going to tell you what we think is going to be on there, we hope. Okay, here we go. This is the summary from our exam 2. So what have we covered since then? All right. Okay, the end of chapter 8. So the last one we covered up through pressure vessels, which was combined loads. Okay. Now the point of this chapter, if you remember, it takes everything that we've ever talked about, transverse shear, bending, P over A, just like elongation, everything, and combines it into one problem. And the goal here really is to take this one really complex loaded member and tell me the stress is on one point. So construct a stress element, at a point, let's say. So take a really complex load, it's twisted, it's bent, it's pulled, and all that, and draw me a stress element for what's going on at point A, okay? These are the ones where we had our effect map. Remember the effect map. Okay, so we'll work a sample problem on that deal. The next chapter we talk about is chapter 9, which was stress transformation. Okay, and if I had to divide the chapter on stress transformation, there's a lot in there. I would divide it into these things, okay? Number 1 would be the equation method. Now, some of you, your professor may give you an equation sheet. If that's true, and maybe this is where you live. Me personally, I hate it. I hate it, okay? Because I can do everything with this one, Moore's circle. I mean, if you can get 2 coordinate points and make a circle out of that, and then make a triangle within that circle, you can get all the information that you need from that. Why would you mess with that? I hate this method, okay? But there it is, okay? Moore's circle. The last one we talk about here is failure theories, okay? Okay, and there's 3 of those. There's Rankine, and there's, let me think. Tresca. And then of the last one, von Mises. Okay? Maximum normal stress theory, maximum shear stress theory, and the stress energy. So, study those. You might need to know that kind of stuff there. Okay? The failure theories. Moore's circle. So important. You got to know that guy. Okay? This is for stress transformation. That was for sigma, stress, okay? Sigma and tau, we could get from that. Now the next chapter, that was 9, so this is chapter 10, was on strain transformation. And if you remember, the equations for stress transformation are the same as equations for strain transformation, except where you saw a sigma before, now you're going to insert a strain, and where you saw a tau before, now you're going to insert a gamma xy over 2, right? But the equations are the same here as they are there. Likewise, Moore's circle works exactly the same, okay? Moore's circle works exactly the same. You have the strain axis, and then you have the shear strain axis, but it's over 2. Okay, don't forget about that guy. So, now in strain transformation, there was one more nifty thing that we learned, we talked about, and that was the strain rosette equations. Okay? There's 3 of those, right? There's 3 equations. Every single one of them is exactly the same, except one's A, one's B, one's C. But remember how to use the Strain-Rosette equations to calculate strain. Because if I use Strain-Rosette equations to get strain in the x and strain in the y and gamma xy, then I could ask you on the test, okay, take those things, and then from Moore's circle with those values, tell me what the maximum strain is. What is the maximum shear strain? Okay, so I can take these values that I get from the Strain-Rosette and then come back up here and have to apply them inside of a Moore's circle, okay? Kind of a 2-for-1 special. We'll do one of those on a sample problem, so stay tuned, okay? Chapter 11 was on beam design, okay? And there's not really a whole lot there in beam design. It's take everything that you've learned this semester and design a beam. How big should it be? So we learned in here how to read like the wide flange beam tables, right? We learned how to do that. We learned how to calculate something called S, okay? If you remember that. The section modulus. Do you remember the section modulus? Section modulus. And that was a thing that we used to look up which beam we were going to use. Okay, so just to select which one we're going to use. That was the other two things in there where there were two little shortcut method. One for rectangular beams where we could say that tau is equal to 1.5 V over A for tau max, right? For max. That was a little shortcut we learned, it works just for rectangular beams. And the other one we learned was, that's not how you draw that, was for I-beams. Okay, we'd use V over A, but we would just use that center section there for A, for the area, okay? If you don't remember that, kind of go back and review those beam design videos, especially I think one's called Tips and Tricks or Shortcuts. That'll help you on that one. Next was chapter 12. 12 is over, this was a tricky one, huh? Slope and deflection. And then finally, chapter 13 is over column buckling. So that's a lot of material. I'm going to have to make y'all a lot of practice problems. That's probably going to be 1, 2, 3. I can get 3 out of that. 4, 5, maybe 6 exam practice problems. So stay tuned. I'm going to work some examples that would be good test questions, and I'm going to show you how to do those. But you push pause and see if you can work them before I do, and then just push play and see if you can get the same answer I got. All right, here's wishing you the best of luck on studying for test number 3. Let's go!